Okay, so now that we know how to find where the minimums and maximums are, let's take a step back and look at a graphical approach, and we're going to see how we can use derivatives and eventually double derivatives to be able to figure out a lot of information about the graph. So I'm just going to draw a random curve right here, like right there. We'll say that this minimum, or this maximum is at x equals -1, and we'll say this minimum is at x equals 4. Just as an example, and this right here is f of x. So there's a couple things we notice about this graph, that there are minimums and maximums here, and also how the graph is laid out. Now we're going to introduce a concept known as concavity. Concavity is the direction of which the graph is curving and which way it's open. It's going to either concave down, which is going to look something like that, or concave up, it's going to look something like that, where it's almost like it's cupping it up, or cupping it, oh, this would be cupping it down, or cupping it up. So, in this graph that I drew for you on the left, this part, until maybe about right here, somewhere I'll draw a little squiggle, is concave down. The curve is pointing downwards. The definition of this is concave down if the tangent lines go above the line, which it does. The tangent lines are above the line, therefore it's concave down. And this one, the tangent line is underneath the line, so it's concave up. That's how you would define it in words. But there is a point right around here where it switches from being concave down to concave up. This point is known as the point of inflection. The point of inflection. Okay, so we talked about in the last video how if f prime of x equals 0, then it's a minimum or a maximum. Well, something you're also going to learn is that the double derivative, f double prime of x equaling 0, that's the point of inflection. Alright, if you were to draw the derivative of this line, then the minimums and maximums of the derivative line would be the points of inflection of the original line. So, with that knowledge, we can actually go ahead and draw out some graphs, and you'll be able to actually find out what the derivatives and even further the antiderivative, or going a step back, would look like without much effort. So we're going to call a minimum, a maximum, or a point of inflection are known as critical values.